Welcome back. In our earlier few classes, we have learned the basic concept of Boolean algebra and its different laws that we need to simplify a digital circuit or Boolean expression, and also we have learned De Morgan's laws. In today's class, we will apply those laws to simplify different Boolean or logical expressions. So let's get started. The first problem says that if a b bar plus a bar b is equal to c, where a, b and c they are Boolean variables, then prove that a c bar plus a bar c is equal to b. So we will start with this expression, the one we need to prove. So here what we will do is we will replace c by the expressions in terms of a and b. So it was a c bar, a b bar plus a bar b was c. So it will be the whole complement of this expression and then plus a bar c. So this is c. Now in the first term, we will apply one of the De Morgan's laws. If a b bar, we take that as a single Boolean variable x, and a bar b that we take as another Boolean variable y, and if we perform OR operation and then complement on that, then it will be as per De Morgan's law, it will be x complement and operation then y complement. We know that plus means here OR operation in Boolean algebra, and multiplication means AND operation in Boolean algebra. So as per that law, it can be written as, now after applying that law, what we can see here is it is a and b bar and then whole complement. So it can be again thought as like x and y and then whole complement. So it can be written as per De Morgan's law, x complement plus or y complement. So the first term can be further rewritten as a complement then plus or operation and then b complement and another complement on that, double complement, and then we have AND operation, and again if we apply the same law here, then it will be a double complement and then or b complement. And from the second term, if we simplify this way, if we multiply these two terms or perform AND operation, then it will be a bar a then b bar and then plus a bar and then a bar b. Then if we further simplify, then it will be a, then it will be a bar and b double complement means we know that will be b, the original Boolean variable. Then we have AND operation, then it will be a, then it will be b complement. And then after that, a and a complement, we know this rule that a and a complement, if we perform AND operation, then that gives us 0. And similarly, if we perform a and a, then that gives us a only. So similarly, if it is a bar and a bar, then that will give us a bar. So the third term, since we have a bar, so that will become 0. And in the fourth term, we have a bar and a bar, so that will finally give us a single a bar, and with that we have b variable. Now if we perform AND operation between these two terms, so it will be a bar and then we will have ab, and then the second term is a then b bar and then we have a bar b. Now a bar, again it will give us 0 like we had here. So here the only term that will be left behind, that is ab, and then here we have a then b bar and then we have another a bar b. So if we further simplify, then it will be a then ab and then we will have a b then b bar and then we will have the third term a bar b. Now again in the second term we have b complement or b bar, so this term will vanish, that will become 0. And in the first term we have this Boolean variable a twice, so finally it will be only single occurrence of a, and then we will have b and AND operation between them, and then we will have a complement b. So it can be written as b will be the common Boolean variable, so within bracket we can write a complement, and we know that a plus a complement is what? For any Boolean variable, that value is 1. So it can be finally or further written as b multiplied by 1, so it will be b only. Now in the second problem, we have to simplify this Boolean expression and we have to find the most simplified answer. So in the first step, what we will do is the first term will remain as it is. Then in the second term, what we can see is if we have this complement, we have first the AND operation, then complement between two Boolean variables AC. So we will apply De Morgan's law here, and then we have this multiplication between these two Boolean expressions or terms. So we will multiply them. So it will be A B bar C, then multiplied by AB, means AND operation, and then we have or plus, and then we will be having A B bar C and then another C multiplied by. Now what we can see here in the third term, or in this term, we have B and then B complement, and we have AND operation between them. So the final value of this term will be 0. And again in the fourth term, we have double occurrence of this Boolean variable C. We know that if we perform AND operation between same Boolean variable X, then the final result of that AND operation will be the same variable only. So here the first term will be AB, then we will have A complement or A bar, then C bar, then we will have A, B bar, and then C only. Now what we can do is we can rearrange the terms, and we can take the first term and fourth term together, and then the second and third term. So from the first and fourth term, here we have now the first and second term. A is common, so that can be taken as common. So within bracket we will have B plus B bar C, and then we will have A bar plus C bar. Now what we can do is we will apply the distributive law of Boolean algebra. So it will be B plus B bar and then multiplied by B plus C, and then we will have A bar plus C bar. Now B plus B bar, that will give us 1, so it will be A, then B plus C, and then we will have A bar plus C bar. So it will be AB plus AC, then we will have A bar plus C bar. Now what we can do is we can again rearrange the terms, and after rearranging again we will apply the distributive law of Boolean algebra. So from the first term we will have A plus A bar and then multiplied by B plus A bar, and then we will have this OR operation, and from the second term we will have A plus C bar, and then we will have C plus C bar. So A plus A bar will give us 1, that we know. So it will be finally B plus A bar and then OR operation, and then again C plus C bar will give us 1. So it will be then A plus C bar only. Now as we can see, we have A plus A bar, so that will give us 1, and then B plus C bar, that will remain in that expression. 1 plus B. 1 plus B is what? If we have a Boolean variable X, then 1 plus X is always 1, that we know. So 1 plus B will be what? 1 plus B will be 1, and then 1 plus C complement. So 1 plus C complement. Complement of C will be another Boolean variable. So that can be written as 1 plus X, where X is the output of C complement. So it again fits or suits this formula. So it will be finally 1 only. Now in the third problem, again we have a Boolean expression that we need to simplify. So let's proceed. Now in the first step, what we can do is between these two variables, this A Boolean variable is common. So that will be taken as common. So as second term, we will have B bar plus BC, and then we have this complement. And in the second term, we have AB plus A and then AB bar. And then we have this whole complement. Now what we will do is B bar plus BC, on this term we will apply distributive law of Boolean algebra. So it will be A, then this can be written as B bar plus B multiplied by B bar plus C, and then we have this complement, and from here it will be AB, and then since we have in the fourth term double occurrence of A, so finally it will be AB bar only, and then we have this whole complement. Now in the next line what we will do is it will be A, B plus B bar will give us 1, and then this term it will be B bar plus C, and then we have this complement. Then what we will do is from these two terms we have A common, so within bracket it will be B plus B bar, and then we have this overall complement. Now in the next step what we will do is it will be A B bar plus it will be AC, and then we have this complement, and here B plus B bar will give us 1, so it will be only A, and then we have this overall complement. Now in the first term, in this term, we will apply De Morgan's law. So it is like x plus y then complement. So it will be x complement and y complement. So it will be a b bar and this complement, and then multiplied by or and operation, then ac, and then again this complement, and then we will have a, and then on overall we have this complement. So this can be further written as, again, a and b bar, these two can be taken as separate Boolean variables, and this is a NAND operation between those two variables. So it can be further written as a complement plus b complement itself is one Boolean variable, and then we will have this another complement, and then we will have this AND operation, and then we will split again this as per De Morgan's law. So it will be a complement plus c complement, and then we will have this a, and then we will have this whole complement. So further if we simplify, then it will be a bar or a complement plus b, and then from here it will be a bar plus c bar, and then we will have this a and this overall complement. Then what we can do is, again, it is a bar plus b and a bar plus c bar. So it's like a plus bc, as it can be written as a plus b as per distributed law, and then a plus c. So from the right hand side, now if we think, a plus b multiplied by a plus c can be written as a plus bc. So a here, it is a complement itself is that first variable a in this law. So it can be written as a complement, which is one variable, then plus b, and then this variable multiplied by this variable, which is again itself is a complement of another variable, which is c complement, and then we have this a and we have this overall complement. So under this complement we have these three terms where a plus a bar will give us 1, right? So it can be written as 1 plus bc bar, and then we have this overall complement. Now this can be further written as, if we apply distributive law, then it will be 1 plus b, and then it can be written as 1 plus c bar, same concept, and then we will have this overall complement. Now 1 plus b will give us 1, and 1 plus c bar also give us 1, and AND operation between them, and then we have this complement. So 1, it will be finally complement of 1, that means it will be finally 0. So this is the simplified answer of this Boolean expression that we have simplified by using different laws of Boolean algebra and also De Morgan's laws. Now in the next problem, what we can see is we have two Boolean expressions on both the sides of this equation, and we have to prove that these two Boolean expressions that we have on both the sides are same, or they will give us same simplified answer. So we will start with the expression that we have on the left side. In this expression, what we can see is we have 5 terms, and between these two terms, what we can see is a bar, b bar, these two Boolean variables are common. And between third and fourth terms, we have a bar, b, these two Boolean variables are common. So we will proceed accordingly. So we will take a bar and b bar common. So from the first two terms, what we will be left in the bracket is c bar and then c. And also from the third and fourth term, we will be taking a bar and b, these two terms common. So what will be left within the bracket is c bar and then c. And the fifth term we will keep as it is. And then from this c plus c bar, we know that this will give us 1. So the simplified form will be, from the first and second terms, it will be a bar and b bar only, and from the third and fourth it will be a bar b, because c and c bar again it will give us 1, and then the fifth term a b bar and then c bar. Now from the first and second term that we have in the simplified answer that we have simplified so far, we can see here that a bar is the common term, so that will be taken as common, and within bracket we will have b bar and then b, and then we have a b bar c bar. So again b plus b bar will give us 1, so it will be a bar only, and then it is a b bar c bar. Now if we apply distributive law, and b bar c bar, that if we take as a single Boolean variable, say x, then it can be thought as a bar plus a x. right? So it can be further written as a bar plus a and then multiplied by a bar plus x. Now if we put the value of x, a bar plus a will give us again 1. So it will be a bar and then x is what? X is b bar c bar. So it can be further written as a bar will remain a only and then b bar multiplied by c bar, or AND operation between b bar c bar, and again we will apply De Morgan's law. So it will be b plus c and then whole bar, and that's what we wanted to prove. Now the next and last problem says that if a bar b plus c d bar is equal to 0, then we have to prove that these two Boolean expressions are same. So for this particular problem, what we will do is we will simplify the left hand side and right hand side separately, and we will show that both the expressions are giving us the same simplified answer. So we'll start with left hand side, then we will follow, and that will be followed by right hand side. Now what we can do is, this is a bit tricky. Now if we add 0 with the expression that we have on the left hand side, then 0 means what? 0, the value of 0 is given, and that is a bar b plus c d bar. So in place of 0, which is nothing, we can write in the first step itself that a bar b plus c d bar. And now if we further simplify, then it will be ab plus a bar c bar, then we will have c bar d bar, and then we will have a bar b plus c d bar. Now what we will do is we will rearrange the terms. Between first and fourth term, we can see that we have b common and we have a and a bar. So we can understand that if we can take b common, then a plus a bar will give us 1. So that way we can simplify first. So AB and then fifth term A bar B we will club or combine together. Then we will find that type of relationship between other terms, or the terms that we are left with. Between third and fifth term, again we have that kind of relationship. So C bar and D bar, and the fifth term is C D bar. So D bar if we take common, then within bracket we will have C plus C bar, and then we will have the second term which is a bar c bar. Now between ab plus a bar b, if we take b common, then it will be a plus a bar, and then between these two terms if we take d common, then it will be c plus c bar, and then we will have a bar c bar. So the simplified form will be, now it will be a plus a bar will give us 1, so it will be b, and then c plus c bar will give us 1, so it will be d bar only, and then we will have a bar c bar, and we will keep that expression, and we will try to simplify the right hand side, and we'll try to show that that expression also will give us this value. So if we can do that, then it will serve our purpose. So now we will proceed with right hand side. Now again we can think that as if we are adding 0 here, and 0 means this expression. So in place of 0 we can write that. So it will be a bar plus b and then plus c d bar. Now again we have to rearrange the terms as per the way we can simplify first. So between first and here it is fifth term, if we combine them, so it will be ab plus a bar b, and then all other terms we will keep them as they were. Now between ab plus a bar b, if we take b common, then within bracket we will have a plus a bar, and that will give us 1. So it will be finally b only. Now we will have this second term bd, then all other terms as they were. Now between first and second term, if we take b common, then it will be 1 plus d. So 1 plus d means that will be again 1 only. So b plus b bar d bar. And here we can apply distributive law of Boolean algebra. So it will be b plus b bar, and then we will have b plus d bar, and then we will have a bar c bar d plus c d bar. So from here b plus b bar will give us 1. Now we have to see which two terms we can combine. So from here what we can see is d bar and plus c d bar, if these two terms, if we combine, then it will be d bar can be taken as common, and within bracket it will be 1 plus c, which will finally give us 1 only. So it will be next, it will be d bar 1 plus c will give us 1, and then we will have b, and then we will have a bar, c bar, d. So between first term and second term, now if we apply distributive law, then it will give us d plus d bar, and then the second term will be d bar plus a bar, c bar, and then we have this b. D plus d bar will give us 1. So finally it will be d bar plus b, and then plus a bar, c bar. And that's what we obtained for the expression that we had on the left hand side also. So this is the way how we can use different laws of Boolean algebra and also different De Morgan's laws to simplify Boolean expressions in digital circuits. I hope you have understood the class. With that, hope I end today's class. Thank you.